8.8, solving radical equations. We've got 4 main steps and then your 5th check to check your answer. Step 1 is solving radical equations means there's going to be a radical and there's going to be an equation. Step 1 is to isolate the radical. Step 2 is to square both sides. Step 3 is to simplify both sides, and then step 4 is to solve the equation. By the time we simplify and solve, these 2 steps will look like what we've always done when we solve an equation. Alright, so I've got a basic one written up here. I've got the square root of x equals 5. Step 1 is to isolate the radical. Isolate means to get it by itself on one side. The radical is already by itself on one side, so step 1 is done. Step 2, square both sides. Square both sides. I'm squaring it because the opposite of taking the square root of something is to square it, which means those are inverse operations and they cancel each other out, leaving me with x. Equals 5 squared is 25. Step 3 is simplify both sides. It doesn't get much more simplified than x equals 25. Solve the equation. X is already isolated, it's already solved, so I'm done. Now I can double check it by plugging this answer in. If x equals 25, then the square root of 25 better equal 5, and it does. The square root of 25 is 5, so it checks. That one's done. Every one that we do beyond this, these steps don't change. The complexity of the equation does, but the steps don't. We always do the same thing. So let's look at one that steps it up a little bit. If I have the square root of x minus 2 equals 5. Isolate the radical, already done. Radical is by itself on one side of the equation. Square both sides. Those are inverse operations and cancel, leaving me with a radicand. X minus 2 equals 5 squared is 25. Step 2 is done. Step 3 is simplify both sides. It's already simplified. Step 4 is solve the equation, which means isolate the variable. I need to get rid of this minus 2. The opposite of subtracting 2 is to add 2 to both sides. And I get x equals 27. So if I was to plug that in, I would get 27 minus 2. The square root of 27 minus 2 equals 5. That would be the square root of 25 equals 5. And we saw just a second ago that that is 5 equals 5, so it checks. Again, isolate radical, square both sides, simplify both sides, solve the equation. Don't let it, just because these get more complicated looking, throw you off from what the 4 steps are. Those 4 steps don't change. The square root of x squared plus 5x minus 2 plus 4 equals x plus 1. I would say we stepped it up. Alright. Step 1 is still isolate the radical. My radical has a quadratic under it, so it looks ugly. I need to get rid of that plus 4 first. I need this radical by itself. Subtract 4 from both sides. Those cancel, and I get the square root of x squared plus 5x minus 2 equals x. 1 minus 4 is minus 3. Step 2, square both sides. I want to get rid of this radical. Here's where we often make a mistake. If I square this side, I have to square the whole thing, which means I'm about to have to FOIL that. This side, the radical and the squared cancel each other out, leaving me with x squared plus 5x minus 2. This side, I'm going to get x squared minus 6x plus 9, and the way I got that was x minus 3 times x minus 3, because that's what it means to square something, is to do this. When I FOIL it, x times x is x squared, x times negative 3 is minus 3x, negative 3 times x is minus 3x, and negative 3 times negative 3 is plus 9. These two middle terms combine, So I get x squared minus 6x plus 9. So when I FOIL it, I get x squared minus 6x plus 9. I've squared both sides. Now it wants me to simplify both sides. There's not a whole lot I can do. I want to solve. The way I solve any quadratic is I need to get it in this form. I need to set it equal to 0. Now what I'm going to notice when I move this, that means I need to move everything from this side to this side. The first thing I'm going to do is subtract x squared. And as soon as I do that, I'm seeing they're going to cancel each other out, which means it's no longer quadratic. So this is no longer what I need to do, but I don't stop doing that until I realize that they cancel each other out. Now it's going to become linear. And the way I solve a linear term is I isolate the variable. So I want to get the x's by itself and everything else on the other side. So I'm going to move 6x over here. And I'm going to move the constant over there by doing the opposite. Opposite of subtracting 2 is to add 2 to both sides. So those cancel out and these cancel out. 5x plus 6x is 11x equals 9 plus 2 is 11. Now solve the equation. I need to isolate the x. 11 divided by 11 is 1. So we get x equals 1. Now just so we know, if these x squareds had not canceled each other out, I would have had to solve it the same way I would any other quadratic, and I would have gotten 2 answers. Alright, so let's look at one that does that. This is nothing new. The fact that we're about to do the quadratic, the only new thing is that I need to isolate the radical, square both sides, and then it looks like anything I've already done. Alright, so if I have the square root of 3 minus 2x equals x. Step 1, isolate the radical, it's already isolated. Step 2, square both sides. That canceling with 3 minus 2x equals x squared. Now I can see it's going to be quadratic. I've got to have it, try it again, ax squared plus bx plus c equals 0. So, because I want this to stay positive, I'm going to move these two things over there. So I'm going to add 2x, and I'm going to subtract 3. All that'll cancel, even with 0 equals x squared plus 2x minus 3. Now all of chapter 7 was factoring. So this should not look complicated. It's nothing that we haven't done. We learned every way to factor the last chapter. Let's go trial and error. I know my first terms are going to be x. My signs are going to be opposite of each other. And I need 2 things that multiply to equal negative 3, but add together to equal positive 2. It's going to be positive 3 and negative 1. Now I've got to solve the equation. The way I solve a quadratic is using the zero factor theorem, that if either one of these factors is equal to 0, the whole thing is equal to 0. So I take each one, set it equal to 0, and solve. Subtract 3 from this one. X equals negative 3, add 1 to this one, x equals 1. So x equals negative 3 or positive 1. Alright. So the last step, I've done it on everyone so far, is to check. So, when I check these 2 answers back into this original equation, I have the square root of 3 minus 2x equals x. I'm going to check negative 3 first. So I'm going to say x equals negative 3. Square root of 3 minus 2 times negative 3 equals x. Square root of 3, negative 2 times negative 3 is plus 6 equals, we're going to change this. X over here is negative 3 also. So here I get the square root of 9 equals negative 3. And the square root of 9 is 3 equals negative 3. That's not true. Positive 3 does not equal negative 3. So that one does not work. It's an extraneous solution. So negative 3 does not work. Let's try 1. I have the square root of 3 minus 2 times 1 equals 1. 3 minus 2 times 1 is 2 equals 1. The square root of 3 minus 2 is 1 equals 1. The square root of 1 is equal to 1. That one's true. So this is our solution. Negative 3 is extraneous. It won't work. That's the reason that they will have you check. Anytime we square both sides of an equation, we're forcing answers, and there's a chance that one of them will be extraneous. So always, always, always check them. Do one more. All right, if I have the square root of 2x plus 5 equals the square root of 4x minus 3. This one looks different because it's going to tell us to isolate the radical, but I've got two radicals. They're both already isolated on either side, so I'm good right now to just go ahead and go to step 2 and square both sides. So I get cancellation of radicals and exponents, and I get 2x plus 5 equals 4x minus 3. Now I need to solve the equation. I want to keep my x positive, so I'm going to subtract 2x from both sides, and then I'm going to add 3 over to the other side. Those cancel, those cancel. 5 plus 3 is 8. 4x minus 2x is 2x. Divide by 2, and I get 4 equals x. When I go to check, I get the square root of 2 times 4 plus 5 equals the square root of 4 times 4 minus 3. 2 times 4 is 8 plus 5 equals 4 times 4 is 16 minus 3. The square root of 8 plus 5 is 13 equals the square root of 16 minus 3 is also 13. The square root of 13 equals the square root of 13. I've got the same thing on both sides. I'm good. So I've got 4 equals x, and that's it. So don't make them harder than they are. You've learned how to handle quadratics. You've learned how to solve, and it's just a linear equation. Just do those 4 steps and then check it every time, especially when you get a quadratic.